Alright, week 1, part 3. We are dealing with rational expressions here. So first we got to talk about the domain, find the domain of the expression. So we have an expression, and you can kind of pretend that this equals y, and it has some graph. What's the domain, what's the range? So by domain we mean what are the appropriate values of x. And so because we are taking the square root, not allowed to take the square root of a negative, meaning whatever's underneath has to be 0 or positive. So you take whatever's under the root sign and you can say x minus 5 is greater than or equal to 0 and solve it, and then here's our domain. So with these questions you basically don't want to, here's your key right here, you don't want to take the square root of a negative, and you don't want to divide by 0. So these are the two big no-nos. No, no, no. Don't take the square root of negative, don't divide by 0. Let's see how this works. For number 2, we have so this is a rational expression, meaning variable, top and bottom. If we were to factor the denominator, the top doesn't look factorable. You see there are two values for which we would have 0 in the denominator. So one of those is 2, so that is not allowed. The domain would be, we could say domain equals all real numbers except x equals 2 and x equals negative 1. These are not allowed. So you could write it like this, or you could say all real numbers except 2 or negative 1. Because those values would produce 0 in the denominator, and that's a no-no. So here we have a situation where we have two things going on. One is the denominator could be 0 at 5 or negative 5, but we also have a square root. And so we're going to have to deal with all of those. Let's see how we do this. Square root shows us that x would have to be greater than or equal to negative 3 in order for us to not have a negative here. Factoring the denominator gives us this, in which case x may not equal 5 or negative 5. So if we just had this, right, just that denominator, it would be, and I'm going to highlight this on the number line, it would be everything except 5 and negative 5. Okay, so that's for this and for this. But when we take this into consideration, this other constraint, x must be greater than or equal to negative 3, well, here's negative 3, and we're saying it's all of this stuff. So it has to obey everything, meaning anything to the left. Uh-oh, this is, let's see, where's my eraser? Oh dear. Alright, here's my eraser. So everything to the left of the negative 3 is not part of the domain because it doesn't obey this, and everything to the right of negative 3 is all good as far as this is concerned except this value. So we would have from negative 3 all the way up to, but not including 5, and then continue on. So with a smaller pen, how could we say that? We could say x is greater than or equal to negative 3 and less than 5, or x is greater than 5, like that. So it's got two separate parts for the domain. Question 4, so simplify. Rational expression. With rationals, you're essentially going to be, if you're confused and you're like, what do I do? It's basically a factor and cancel. Not all the time, but most of the time. Factor and cancel. Cancel? 2 L's? I don't know. 1. So if we factor numerator and denominator, we end up with this. Notice how x plus 4's cancel. They're out of there. And so what we're left with is the x plus 2 over x plus 1, and voila. Very nice. Factor, cancel, simplifying rational expressions. Number 5 looks similar, so we got a bunch of stuff, multiplying a bunch of stuff, fraction times fraction. So this right here could be factored, x plus 5 times x minus 5, and x plus 4 times x minus 4. And it's all numerator being multiplied and all denominator being multiplied. So x plus 4 cancels with x plus 4, x plus 5 cancels with x plus 5, leaving us with, and just coincidentally they were right there in the middle, our x minus 5 over x minus 4. Please don't, no, do not say, oh, and then the x's cancel, giving us 5/4. No way, no way. Let's get rid of that. Okay. Number 6. All right, woo! So, similar sort of situation. We have a rational, but this time it's divided by. You know, dividing by a fraction, same as multiplying by the reciprocal. So what I did is I factored this and wrote it up top, just in one big step. I was worried about running out of space. So factored this, put it up top, factored this, put it down below. Again, factoring with that 2 gets a little tricky, but we can handle it. X plus 3 up top, and then 2x minus 3 and 2x plus 3 in the denominator. So again, after we have flipped this, we are now multiplying all that. That's our numerator. Multiplying all this. This is our denominator. So anything from up here will cancel down here. If this were plus or minus, that would not be the case. 2x minus 3's are out of there. X plus 3's out of there. And we're left with this over these. So x plus 5 over 2x plus 3 times x plus 4. Factor, cancel. Yeah. Number 7, deceptively simple. So this is a fraction within a fraction, or complex fraction. And I don't like calling them complex fraction because it implies they're difficult. A is the same thing as a over 1. This is frequently helpful. B over c. So dividing by a fraction is the same as multiplying by the reciprocal. We will do a lot of that in this class. And so we end up with AC over B. Okay. Let's take a look at page 2, see what happens. So we are now adding and subtracting. So we're going to be dealing with common denominators, all right? Least common denominator for a lot of these situations. So in this case, our common denominator would be these two being multiplied together. So what I've done is started with the first term here and the second term here. We're color coding in order to get the LCD. So in this case, our LCD is x plus 5 times x minus 3. All right. So we multiply both top and bottom here by this in order to get our LCD. And then over here, multiply both top and bottom by x plus 5. Remember, this is 1. You can multiply by any form of 1. You just multiply both top and bottom by that. So we end up with this, 1 times x minus 3, and then plus 2 times x plus 5, all over our common denominator. Voila! So the difficult part in these types of questions, I think, for students is usually figuring out what is the LCD, and then this step, how to turn our terms into things with the least common denominator. The rest is pretty straightforward. So now we're just simplifying everything up top. We have x minus 3 plus 2x plus 10. So I think I skipped a step there. And x plus 2x gives us 3x, and minus 3 plus 10 gives us plus 7. So there we go. Alright, 9, similar situation in this case. And this would be helpful. I know that I didn't, but now I'm doing it, writing out what the least common denominator actually is. this would be x squared times x squared plus x. You don't always just multiply the denominators, as we'll see in the next example, but here, both of these, we could do it one step easier. So if you want to solve this on your own, we could say that the least common denominator is x times x squared plus x. But it won't make it that much easier. So this term we multiply by x squared plus x, and this term we multiply by x squared over x squared. And in the numerator we now have this. We're going to simplify this, so distribute here the 2 and then combine like terms. So we end up with 3x squared plus 2x over this. And then, so do you see as this last step, what I actually ended up doing is factoring out an x from here and from here, giving this. So I think if you had used that as your common denominator, you would have avoided that factoring step. So this again was factor out an x, because there was one common to the numerator and denominator. Alright, that's the next one. So let's take a look at question 10. Alright, so here we're not just multiplying the denominators to get the LCD, and that is because this guy, x squared minus 25, that's the same thing as x plus 5, x minus 5. So if it factors, and one of those factors is common with this, then this is the LCD. So that's the LCD. Nothing changes in this. And if you do that, it'll really simplify things. Over here at the left, we do need to multiply by x plus 5 over x plus 5. So we have 3 times x plus 5 plus 1 all over x minus 5 times x plus 5. Who wrote that? Oh, I got it right over here. Okay. And then let's see. Distributing 3x plus 15, and then plus 1 gives us the 3x plus 16. Okay, that was cool. Number 11, look at this crazy stuff. Man, that was fun. Alright, so we have a big fraction, and we have fractions within that fraction. So what I did is I looked at the numerator all by itself. So looked at, I know that's probably pretty fuzzy, I looked at just this stuff, and I'm doing least common denominator here of x plus 2, and then looked at the denominator all by itself and said, alright, we're going to have a common denominator of x plus 2, and so that step is then over here. So this becomes x times x plus 2, that's this, plus 1 all over our common denominator of x plus 2. So this becomes this. And this over here, we have x times x plus 2 minus 1 all over our common denominator of x plus 2. And there's going to be some canceling here going on. So we have fraction divided by fraction, same as multiplying by the reciprocal. So this is this, and I'm multiplying by the reciprocal of this. So this gets flipped. X plus 2 ends up here. That stuff ends up here. So I'll color code. This is this. This is this. And I suppose highlighting would work too, but and this is this. And this is this. Okay, so some color coding. Maybe that's helpful. Our common denominator right here. Where'd blue go? And our common denominator here. Alright, so there's some color coding. I don't know how you're going to put that in your notes, but you can figure it out. So now that we have done that, alright, we're now multiplying these, so we have the entire numerator and the entire denominator. So this and this are going to cancel out, leaving us with the orange over the red. Ooh, some more color coding, that looks good. The orange over the red. Alright, and I know it's tempting to see x plus 2 and x plus 2 and cancel, but you can't because it's not the entire numerator being multiplied. Up here it was, because it's all of this being multiplied by this. And I know that that is definitely a source of confusion, but the more you practice, the more sense it will make. So we're not allowed to cancel this stuff here. We're going to distribute and then see if we can simplify. So we get x squared plus 2x plus 1, and we get x squared plus 2x minus 1, and I think one of those is factorable but not the other. Yeah, so this is factorable, so we'll go ahead and factor, and it'd be cool if this were factorable and there were more canceling, but sometimes that's all you get. So, whew, there you go. Alright, and lastly but not leastly, of course, rationalize the denominator. So rationalize means get rid of radical in denominator. And we've done some of this, but here's the sort of trick. Is sometimes we call this the conjugate in other applications. So we have 2 minus root 3. If you switch it up and call it 2 plus root 3, when we end up foiling, the square root disappears. And it always does that, which is why we do this trick. So we're multiplying top and bottom by basically this with the sign changed. So watch what happens. I have foiled F, O, I, L. So firsts, outers, inners, and lasts when we're talking about this. So firsts, outers, inners, and lasts. Notice here, square root 3 times square root 3 is 3. That's by definition, and it's a minus sign. And so what happens, you see how we have a positive 2 root 3 minus 2 root 3. Those are out of there, and that always happens when we do this trick. So up top, 2 plus root 3 over 4 minus 3, which is 1. So we get a 2 plus root 3. That was nice and simple. I can go for that. Rationalizing the denominator. So let's see what happens over here. I think we have a similar situation. Alright, 1 over 3 plus root y. So notice how I am multiplying top and bottom by 3 minus root y. Same as the denominator, only the sign has been changed. And we're going to firsts, outers, inners, lasts, foil. Notice how the middle terms cancel. Notice how square root y times square root y is y. Why? Ha! You know why. Alright. And so up top, 3 minus square root y, and the middle terms cancel. Most definitely. And we have a 9 minus y. Yeah, there's nothing else we could do. Well, I suppose if we wanted to get fancy, which of course sounds fun, right? We could factor this into a 3 minus square root y and a 3 plus square root, that's a square root y. Woo! And then these would cancel, although then we have a square root in the denominator. Let's just pretend I didn't say that. Alright, sounds good. Got to choose the biggest marker we can. Okay, so we're going to call it good. Thanks for listening.